All right, so I've been trying to think of topics that I can cover, and usually it's like a library or something that, or some specific thing that I can do a deep dive on. But I decided to go a different route this time, um, and what I'm thinking of do what I want to do is go from start to finish developing an application. Now, this is something that I actually want to write for myself because I am unhappy with the current solutions that are available. And I thought I was going to write this whole thing in a fit of rage, on this last weekend. And then I got bogged down reading library documentation. So I didn't get as far as I wanted. And then by then, I mean, my head had cooled off. And so I wasn't as excited about, I wasn't as furious about the problem anymore. And so I was like, you know what, this is good. This is good fodder for the users group. So what we're going to do is we're going to write an application start to finish. We're going to write requirements. We're going to write a design document. We're not going to get too bogged down in the design document because from experience, um, trying to map out every single little thing in the design document is a fool's errand because you always miss stuff. You always forget about stuff, and you don't figure that out until you're actually writing the code. Um, Philosophically, something I've heard that was a really good um, approach to this is like the only design document that you write as a programmer that really actually matters is your code. And it's like, well, isn't that your implementation? No, that is not your implementation. Your implementation is the compiled executable, which is created by your compiler. So um, when you're designing something, the actual concrete design that actually matters is your source code. And so if you missed something in your design document, you didn't precisely define your APIs, or you don't document a specific edge case, don't get too worried about it because that's always going to happen and there's no preventing it. Based on that, let's start by writing up our requirements, and then we'll write our design, and then we'll go from there. And you'll notice that I've already stubbed out some of the things. This is a side effect of me trying to start on this project on this weekend and not getting very far. So what are we writing? So this is going to be Kyle's feed reader. And this is an RSS feed reader. And so the first question is why do you want to make this thing? And so I have certain preferences when it comes to when I write a feed reader. It needs to run locally. It needs to be fast. It needs to have a particular layout. Now, I'm going to call this the 2-panel layout. Most feed readers use a 3-panel layout, and it's obnoxious. It needs to inform me of updated feeds. It needs to check feeds automatically. For fun, it's going to be text-based. I am not actually going to write use a UI framework to present this. It needs to work in Windows. Let's see. What else? Oh, and then let's see. The nice to haves are going to be things like downloading enclosures. And an enclosure in an RSS feed is usually what it is it's a link to some piece of media. So if you are subscribed to a podcast, your enclosure would be something like would be like an MP3 of the podcast. So the feed reader that I'm using currently, you can subscribe to a channel, and you can, or there's a setting that you can say automatically download the enclosures, and it's handy most of the time. Now the problem with the feed reader I'm using is it puts the enclosures somewhere, and it's easy to forget about them. And next thing I knew, the data for my feed reader was taking up like, several gigs worth of space, and it was like videos and stuff that it had just downloaded automatically that I never even watched, or I went to the YouTube page and watched the video and completely forgot that the enclosure was there. So we want downloading enclosures, downloading / managing, managing enclosures. Let's see. Another requirement is, and this thing right here is the thing that actually is driving me to write this application. Compatible with Order of the Stick, which is a webcomic feed, and Newegg's daily deals feed. DAI daily, not daily deals feed. These are the two feeds that I found that my feed reader does not work properly with. And with this webcomic feed, it has to do with the way that the feed is presented. He like never truncates old things in his feed, so the feed literally has 1,200 items in it. And for some reason, the feed reader that I'm using, once you hit about somewhere in the 900 to 1,000 items in the feed, even though you've marked all of them red and they're not showing, it was causing like slowdowns and serious issues with the feed reader. So I had to drop that feed out of my feed reader. And if I want to check and see if there's a new comic posted, I have to go and check the site manually. And it's not a web comic that has a regular schedule. It's very random, which is exactly why I want to use a feed reader for it. And then the Newegg daily deals feeds, or pretty much any of Newegg's feeds, are just broken. They will cause my current feed reader to get bogged down, and it just won't work. So this line right here is the reason I'm actually writing this application. Let's see. What else? Let's see. We need a way to add and manage feeds. And let's see. I'm trying to think of, and I'm sure I'll think of a few other things as we go along. So then, let's see. We need to, and some of these seem obvious, but we have to state them because it is going to come up in our design. We need to persist which feeds have been read, or which articles, let's just call them items, have been read. Yeah. So now we need to start. Let's go. Okay. So now we have a basic set of requirements. Needs to open page item refers to. Now some of these are pretty trivial to implement, but we just have to mention them. Let's see. Automatically checks feeds automatically. May check feeds manually. Group feeds by feed. Well, let's just call it feed grouping. And importing. Well, we'll put this in nice to have. Import, I think it's OPML files, which is a common format for representing a group of feeds. So so for instance, the feed reader I currently use, I can export all of my a list of all of my feeds in an OPML file, and then which is a basic XML file with a pretty run-of-the-mill simple schema. I've looked at it. Writing something that can parse that and ingest it into this application should be trivial. Okay, so let's see. So yeah, that's and let's see. Let's say shortcut keys for much of the functionality. Okay. So yeah, so that gets us our start. So let's do this side by side, split vertically, close that, open that. Okay. So now we need to design this thing. And since it's text-based, that's going to kind of dictate to us what libraries we can use. And now some of these requirements, like the fact that it's text-based, is also just an excuse for me to be able to use, try out some libraries. Like I'm also using this as an excuse to learn an ORM, for a database ORM, instead of just writing SQL queries by hand, which is what I usually do. Also, one of the libraries has some benefits that will make that will allow us to do asynchronous communication with our SQLite database out of the box. Also, let's see. Queries and updates should be async. Okay. And this does affect, and that requirement does affect our design. So what are the parts of our application? So the first thing we need to discuss is we need a data model for the feeds. And this is going to inform us how we create, how we design our database and how we use our ORM to wrap up our database tables. So, so let's look at this guy. And I don't have any notes for any of this. I am winging all of it. So if you have like input that you want to give me or suggestions, I'm all ears. And we'll keep coming back to the requirements document because there are going to be things that I've forgotten that I'll just keep dumping in there. I know, I'm pretty sure I already said that.
Which ORM are you going to be using?
So my original thought was I was going to use SQL Alchemy. But since I want things to happen asynchronously, I was like, well, I got to do this in gEvent. If I'm going to do any sort of database communication, I need to have that running in a separate thread, and there's, and then I've got to have ways to, queue queries into this thread and get them back out. And I know how to do all that in gEvent, but I was looking at SQL Alchemy alternatives, and one of them is Pewee, and Pewee comes with a gEvent wrapper.
I've used Pewee.
Okay.
What about async rather than gEvent?
I want to use gEvent because I like gEvent.
Fair enough.
And
so requirements document requires gEvent.
well, yeah, but that's more because I don't have enough experience with async, and it's just gEvent is better. And if I wanted to do async, there is Tortoise ORM, which is got async support built in. It's basically allows you to do your queries asynchronously using the Python built-in async framework. But I'm more comfortable with gEvent, especially because some of these other requirements, I already know how to do them out of the box, or I know that library wrappers exist for the libraries that I want to use in gEvent already. So that's kind of what's driving that decision. Now, like I said, I can use any ORM I wanted to with Geovent. I just know that there's a certain amount of overhead involved and it's stuff that I've already done. I mean, if you look at in Voltron, if you look at the base historian, with you couple that with the async call functionality that just comes with Voltron. I mean, it's there's an example there of how to do all of this stuff, but I want to see if I can take advantage of Peewee's built-in Geovent async support and see how well it works. Okay, so so our data model for our feed. So what do we need? What do we need to know about our feed? So we have a group. So each feed belongs to a group. We have the feed's URL. We have the name of the feed. And so let's see so for each feed, and it's implied that each feed is going to have an internal ID because we're putting it in a database. And then we have data associated with the feed. So so then we have feed items. And our feed item is going to be things like it's going to have its own ID, and then it's going to have ID of feed. And maybe I need to think about the nomenclature here, because we have feeds and then we have feed items. So the feed is like, here's general information about this feed. Here's its URL. Here's its name. Here's what group it belongs to. Then the question is do we really need anything more than that to describe an individual feed? Now, I might have to crack open my own feed reader and look and see what kind of stuff that they put in there. But there's probably settings for each feed that we might have to add into this as we go forward. So again, the design is never going to be complete until we write our code. So for the feed item, we have the ID of the feed item, and we have the ID of the feed that what feed it's actually associated with. So if we there's also a home page for the feed. So these are all things that when you get a feed for the first time and you go through the items in the feed, you can say, okay, this is where this feed is from, and irregardless of which specific feed item you're looking at. So so some of these are things like, when we add a feed to our application, we're just going to give it a URL. Everything it's going to go query that URL, and then everything else is going to come from our first query of that URL, like the home page, the name. The ID will just be something that we assign it automatically, or our database will assign it automatically. And when we organize it, we'll give it a group, and we'll give it a URL, and everything else will be figured out automatically. So feed items, what makes up a feed item? So we have the ID of the feed item, we have the ID of the feed that it belongs to, and what else? We have let's see, we may have an enclosure. We will also have the text of the feed, the URL of what this feed is referring to. So if you've never used a feed reader before, you can always click on the headline of the feed, and it will take you to the web page associated with where that feed's data is coming from. Now the question, so actually this is a nice to have. open links in feed text. This is actually not a requirement, because if we really want to do that, we could probably just open up the web page and then just follow the link from there. Let's see, enclosure text URL. That's all I can think of for right now. Okay. So data, so let's call this data models. And let's see, feed. And we'll say, all right. Technically, this is Markdown, not Markdown, restructured text. So we have feed items, we have the feed, and that's all I can think. I know, I'm pretty sure there's a third. Oh, we need information about each group. So this is going to be a group ID. So our group, as far as I can tell, is just going to have a, well, it's going to have an ID and it's going to have a name. Okay. So let's see. Do we need to do anything with, so then the, let's see. If we're going to download an enclosure, so we have the enclosure URL, and so we probably won't actually present that to the user. We'll give them an option to download the enclosure, or maybe automatically download it. But if we're going to download it, then we need to remember where we, what its name is and what it ended up being called on disk. So we'll call this enclosure URI. Okay. And this looks like a pretty solid data model. I can't think of anything that's missing. And this might actually be the extent of what we put in our database. Oh, let's see. I'm going to put that as unread question mark. We need to know whether or not a feed item has been marked as read. Because if we want to be able to filter based on read or unread items. So that's a thing that we need to do. Okay, can anybody think of anything else? No? Okay. All right, so here's our data models. Let's see. Now we need to describe our interface with these data models. So the design, so we're assuming that this is going to be put into some sort of database. And you'll see that I've already got some relational mapping stuff in here. Like I've got ID, ID of feed, and then for feed, I have group ID. I have a general ID. So we have we actually have a way that we can go from group to feed items. And it's a pretty simple schema, but it'll do. All right. Shant, you just blew your nose into the microphone.
I'm so sorry. I didn't realize I was muted.
It's okay. It's all right. It's all right, man. Okay, so let's see. What's the next part of our design? So we need to come up with some sort of way of communicating these. We need to be able to create feeds. So we need an interface to our database controller that will allow us to something that we can instantiate, that we can point it at a we can point it at a database, either a SQLite or something else. Although I think we're just going to stick with SQLite, and that we can and we can use that interface to create and remove and do different things with our database. So I think this is the extent of our data model, because in my head at least, everything. Well, actually, the other thing we could do is we can have settings for a feed reader. So feed reader settings, and we'll go ahead and do that. And then this is just going to be it's just going to be key value pairs for different settings. We'll make a note here, not to be stored in DB. So it's probably and examples of things that we're going to want to have in our feed reader or our settings file. Okay. Examples are going to be like DB settings, enclosure, download directory, and I'm sure we'll think of more as we go along. Okay. So that's the extent of our data model. So let's look at how we're going to interface with our database. So we need some sort of so I'm going to make a note here in database, and you'll notice that I'm not calling for a specific I'm not calling for a specific database in my design, so that it gives us some flexibility going forward. If we decide that, oh, SQLite's a bad idea, it's not going to be a bad idea. But if I was doing this for real, I would say I wouldn't specify SQLite database in here. I would just say in database, here's our model that we're going to have. Let's see, config file. Let's go ahead and do that and that. Okay. So let's see, database interface. Okay. Nope. So now we're going to describe what our database interface is going to look like. And we're going to leave out some high-level details like, well, it needs to be a class, and this class needs to have these methods, and the methods need to have these variable names. That's for us to work out when we're actually writing the code, because sometimes it's not, when you actually get down to writing the code, it doesn't work out that you're going to put something in a class, or you're going to put something in a method, or you might use properties for some of this interface. And so we don't necessarily know that going into it. About the only thing we know is we want to have functions, and they want to have these variables passed in the types, and it's too early to get specific about that stuff. And in my personal opinion, I'm fine waiting until we get into where we're writing code that we deal with exact data types. Uh, um, that's the more appropriate place to suss that out, because if you try and do it now, you're going to spend a lot of time, and then you're going to on it, and you're going to be wrong in places, and it's a more efficient use of your time to do this when you're actually writing code. So so we need to have a method to add. So we need to be, and I'm gonna write this using following PEP8, just because that's what my brain does automatically these days. So we're gonna add feed, and so we need the group that the feed belongs to, if any. Let's see group. I'm going to put optional. Let's see name. Let's see URL. Homepage. Page and homepage name. Homepage name URL. The ID is furnished for us automatically. So, okay, so that's how we add a feed. Then we're going to have the equivalent remove feed. And we can do it either by feed ID or by feed name. So we probably we can do this feed name ? Because I'm not sure. Okay. Let's see. Then we have add. Let's see. Get. Then we have get feed items. And then we need to decide how we're going to get feed items. So we can do so basically this is going to just, all of our arguments here are going to be things that we can filter our feed items on. So it'll be like group or or group and or feed and or unread. Let's see, and or I think that's everything. Okay. And so the easiest way to do that is to do like just keyword arguments that default to none in Python. But like I say, we're not going to worry about those kind of details right now. So then we are going to let's see, mark feed item. Let's see. I think now this is an interesting question, because there's two things that you can do here. You want to be able to mark feeds red, obviously, but you also want to be able to mark them unread if you accidentally mark them red. And so so we can do mark feed item. We can either put it into separate functions, or we can combine multiple, the read, unread. We can do it with a single function, which I think is what I'm going to do. So mark feed item, and then we'll do read, and let's see, and we'll, just so we're clear, this is a bool, and then yeah. So Now get feed items. So this is, we have to remember that this is a database interface. We're not going to need to do things like what's the enclosure URL for this particular feed item. If we've already gotten the feed item and we already have it in memory and we're displaying it, we should already have that information. So we don't have to ask for we don't have to have an interface for asking for very specific things. We're more worried about querying for items, querying for feeds, and then changing the state of items and feeds in our database. So let's see. And then another thing that we want to be able to do is, and this is something that my, let's see, nice to have. Let's see, delete old red feeds, feed items from DB. And so we don't want to keep the red items in our database forever, because if we subsequently query the feed, like a lot of feeds only have the 10 most recent items, and so stuff will drop off of the actual feed. And then, but your feed reader will keep it around as a red feed that you can say, oh, let me show me all of the red and unread feeds for this particular feed, and it'll just go on forever. Some feed readers will will allow you to truncate that. So you can say only keep 50 or so unread, only most keep 50 unread feed items. But this generates its own problem, because I've done things where I've had a feed that I just got way behind on, and so but I'd only was sporadically reading things from the feed, and so I had to set, in order for it to not delete the things that I had not read, I had to tell it no, keep things forever. And so it just created this huge blob of stuff that I'd already read in the database. And so we need to make some sort of distinction where we can say, how about you only keep around things that are either unread or are still in the list, or even if they are read, don't keep more. We need a little bit more flexibility than the logic and common sense than the logic that my old feed reader had given me. And that's part of the reason why compatibility with this particular feed was so bad, is because things were not dropping off of the author of this feed doesn't drop off old items off of the feed. And so my feed reader didn't know what to do with that. And it was a problem. Okay, so we're going to mark feed items. Let's see. Then we've also need delete. Let's see, mark feed item. And so we need the, let's see, item ID. Okay. Let's see. So we need the delete feed, or let's see. We need to be consistent here. Delete feed, delete feed item. And then let's see. So we want item ID. And then we can do things like, so we can do item ID and or feed, let's see, the feed ID and or read and or read. So this essentially gives us a simple filter interface that we can use to say, hey, I want to delete all of the feed items from this feed, and here's the criteria I want to use, just so we have and let's go count. Leave count. So that we have a way of saying, yeah, but always keep around at least 50 or something if we find that that becomes a useful feature. Okay. So now we have our database interface. So then this is where it gets kind of murky because it's really up to the individual libraries that we elect to use that really defines our interfaces going forward. So, and there's probably some database interface stuff that I'm leaving out here that I'm forgetting, which is, again, why you shouldn't get bogged down in making your design document perfect. And as we think of things, we'll come back and add them in. Let's see. Okay. So then we need to, well, I think that's it. At least for our design documentation. So let's look at what libraries we're going to end up using here. So I've already come up with a requirements.txt, and you'll notice that I had SQL Alchemy in here. We're going to take that out and we're going to replace it with Peewee. Okay. So part of this like I said, part of this exercise is an excuse to learn for me to learn particular libraries. So the first one is Aschematics, and it's basically a modern version of Curses that's cross-platform. It's a lovely library. I haven't done a presentation on it yet because I never felt comfortable enough in my understanding of the library to use it. And then I read over the documentation over the weekend, and I realized that it wasn't as bad as I thought. So we're going to use the latest version of Feed Parser, because the current version on Git is like 2 weeks old. The current version on Pippy is several years old. So, and it looks like there's bug fixes and stuff in the Git repository. They just haven't bothered to put out a new release. For managing for finding the location of and modifying our configuration file, we're going to use Click, and we're also going to use Click because if we're going to do importing an OPML file, probably going to happen on the command line, although I'm not sure. We may put an interface for it in the program itself, but any command line arguments that we want to add are going to be done with Click. In order to download enclosures, we're going to use requests. Because we're going to use gEvent, we're going to use gRequests. So that's, and then for testing, we'll use PyTest, but I'm not going to put that in here as a requirement. I'll probably move all of the requirements into setup.py, which I haven't even started yet, and then we'll go and so you can do like a what is it? You can do like I don't know if you can do a setup py test. And then the other thing is the other thing that makes Click nice is if you're going to create this as a program that you can that you're going to write a script for, Click enables that well. So the Click documentation assumes that you're going to write your application as something that can be called with the command line without calling Python. And so Click makes setting that up pretty easy. Okay. Well, I've been rambling on for 50 minutes. I think we're at a good stopping point. Now, I will say that I do plan on working on this outside of the office hours, and I will come back and explain what I did and why I did it, and so that you won't miss out on anything. But yeah, and then we'll continue to work on it as we go. The other thing is when I start coding this stuff up, I'm going to be talking less because I find that I'm finding that talking while typing it's making it hard to press forward constantly. So does anybody have any questions? Is there anything off on a different topic that you would like to ask about? If not, we'll go ahead and call it a meeting.
Kyle.
All right. Oh, we have chat.
Thanks, Kyle.
Yeah, no welcome. You're welcome.
No welcome, huh?
No, well, you're welcome. Words.
Words are hard. Tough.
Words are hard. Okay.
Thanks, Kyle.
You're welcome. Glad you liked it, Casey. I'll see you guys in 2 weeks.
See you.
Bye-bye.